So hello everyone. So today we'll be discussing about the Radix sort algorithm, right? Previously, I think we discussed about quick sort. I think so. Previously we discussed about the quick sort. Today we'll be going with the Radix sort, right? So the main approach will be the Radix sort basically works by sorting the numbers digit by digit. So I'll just go by step so that you'll understand this one better. So Radix sort, basically what it does is, here it will work by sorting the numbers digit by digit. So it will sort the numbers digit by digit. So that is how this works basically. So starting from the least, it starts from the least significant digit to the most significant digit. So it starts from least significant digit to the most significant digit. So this is how a Radix sort works basically. For each digit, it performs a counting sort. We have already seen, we already saw how the counting sort works. So if you haven't followed the counting sort, you can just go, you can just see the video there. I have uploaded before this one. Before the quick sort, I have uploaded about the counting sort, I think. So you can just watch. So if you don't get here, I mean, if you are not getting what the counting sort here, you can just go and watch that one, right? So for each digit, we are performing a counting sort. Counting sort is basically stable, meaning that elements with equal digits retain their relative positions, ensuring that the sorting by previous digits is preserved. So by this time you'll be knowing the counting sort, right? So I don't have to explain this one again. So the number of passes the algorithm needs, it will depend on the number of digits in the largest number. So what digits in the largest number, how many number of digits are there in the largest number, that will depend on the number of passes that the algorithm needs, right? So this we have to keep in mind mainly when we are performing the Radix sort. Basically, Radix sort works by sorting the numbers digit by digit, starting from the least significant digit to the most significant digit. So for each digit, as I have said, we will be performing the counting sort. Counting sort, I don't have to explain this one much. Next step is, here the second step is, we are performing this one. For each digit, what we are doing, we are performing the counting sort. So the third step is, here as I have explained, the number of this one, the number of passes depends on the number of passes here needed depends on what? So depends on the number of digits and largest number. Here number of digits and, I'll just write dig, in largest number. So I'll just here largest number, I'll just give here. So this is the third step. Finally, what we will do, the fourth step is, the array is progressively sorted based on each digit. So why we are doing that? Well, we have to ensure that the final array is completely sorted after all the passes, right? So the array is progressively sorted based on the each digit. So here array is progressively sorted. Here I can just write here, array is progressively sorted in based on each digit. So here this is the fourth step. So here this will be the approach. So while writing the code, you'll get to know, and while writing the code and while I take the example, you'll clearly know how the Radix sort works. I'll make sure that. So let's start writing the code, and after that we'll discuss the time and space complexity, right? So this will be function. I'll just consider Radix sort of parameter. I'll just consider the array. So we have to find the minimum number in the array to know the number of digits that we have to process, as we had discussed in the this one approach. I'll just consider max equals first. Let's, how many number of maximum this one are there, right? So that we need to know. So I'll just make use of the math.max. So how many digits are there in the largest number, that we need to know. So I can just make use of math.max and here I'll be using the spread operator. So we'll get the maximum value, and let me give exp. Let me set this one to initialize this one to 1. Nothing but we are starting with the least significant digit, right? So we have to start with the least significant digit, then we have to move to the most significant digit. So here the initialization is done. Next we will go with the iteration. Nothing but we will write the loop until we have processed all the digits. Nothing but until exp becomes larger than the maximum number. This exp becomes larger than the maximum number. Until that we will be carrying on the this one loop. So I can just write here while of math.floor here of max by exp. So if it is greater than 0 here, then I can just make use of the so here we have to make use of the count sort by digit function. So we have not written the count sort by digit function yet, so we'll be writing that one in the future. So first thing is, let's write the count sort by digit. So we have to perform the counting sort for the each digit, right? So as we had discussed in the this one approach, so for each digit we will be performing the counting sort, because counting sort is stable, meaning that elements with equal digits will retain their relative positions, right? So let's perform the counting sort for each digit. Then we will come here again, we will perform the counting sort for the current digit, right? So let's write the counting sort digit. I'll just leave the space for now. So we'll continue once we are done with the counting sort by digit function. I'll just write this one quickly. Function count sort by digit of array exp. This one I'll consider. So first one will be, I'll just consider this one output. So this is nothing but we are creating the output array to store the sorted elements temporarily. So we have to store the elements, sorted elements temporarily somewhere, right? For that purpose, I'll be making use of the output array. So here let's initialize this one. So quickly I'll just write new array of this will be length of the array, and let's fill this one initially with 0. So next let's create the count array for each digit, nothing but 0 to 9, and let's initialize it with zeros. So this will be const count equals again. So it will be size array of size 10, and then we will consider this one to 0. This is nothing but what we are doing in this step. Second count means this one will be output, right? This count, this line, what we are doing here, we are creating the count array for each digit, nothing but from 0 to 9. From 0 to 9. Again, I'm telling, we are creating the count array for each digit 0 to 9, and we are initializing that initially with zeros. So after this step, let's store the count of occurrences of each digit in the current place, nothing but exp, right? So for that, I'll just we are done with the initialization. Let's go with the iteration. Here, this will be I equals 0, I less than length of the array, and I plus plus. So next, let's extract the current digit and let's increment the count for this digit. This will be easy. I'll just give digit equals, let me make use of the this one. This has to be just equal. So I'll just make use of math.flow. This will be iterated value of the array by exp by 10. So we have 10 numbers, right? 0 to 9. I'll just give module 10. So we are just extracting the current digit. Then we will count the digit. So we will increment the count for that particular digit. I can just write here count of digit will just increment this one. So I hope this is clear. Next part is we will modify the count array so that iterated value of the count contains the actual position of this digit in the output array. In simple terms, again we'll be continuing with the iteration itself, right? So I can write in this way for let I equals 10. So sorry, I equals 0, right? Or we'll start from 1. Yeah, I less than 10. Let's increment the I. This has to be iterated value of the count. This will be this is equal to the count of I minus 1. So I hope this is clear till here. We are accumulating the counts to get the position in this step. So after this step, this is important. So here we are building the output array by placing the elements in the current position according to the current digit. So according to the current digit, we will build the output array by placing the elements in the correct position. So we will be going with the reverse iteration, nothing but we will process from the end to maintain the stability. So again, let me make use of the for loop. As I have said, we'll be going with the reverse iteration. This will be length of the array I greater than or equal to 0. This will be, let's decrement the I. After this, let's get the current digit again. So again, let me make use of, this is similar to the previous one, right? So I'll just give here digit. Let me give math.floor of iterated value of the array by exp again. So I'll just make use of module 10. Module of 10, nothing but we are getting the current digit again. So next I can perform I'll just perform the same thing. Output of here within the array count of digit. So this is equal to, this has to be digit minus 1, right? So this has to be equal to iterated value of the array. Next, finally, we will decrement the count for this digit. So this will be count of digit minus, nothing but we are decrementing the count for this digit. So finally, what we will do, we will copy the sorted elements from the output array back to the original array. So we have to obviously copy the sorted elements from the output array back to the original array, right? So for that, I'll be making use of for loop again. This will be I equals 0, I less than array dot length, and let's increment the I. So this will be iterated value of the array equals iterated value of the output. So we are just overwriting the original array with the sorted values for this particular digit. So this is it. So now what we have the counting sort digit, right? So just give me a second over here. So we are having the counting sort by digit function. So let's carry on this one. So I had left the space here, right? So here what we are doing here, so we are looping until we have processed all the digits in the Radix sort array. So now I have already written while math.floor of max by this one exp. If it is greater than 0, then we have to perform the counting sort for the current digit. So I can just write now, I already have the function counting sort by digit, and here I have the parameters array as well as the exp. Within that, I just mention the same. And finally, what we will do, we have to move the next digit place. So this is nothing but exp equals exp into 10, right? So I can just write in this way, exp equals exp into. So I hope this works. Let's see with the example usage. So I'll just come here. So let me consider the example. I'll just give const array as usual. Here I'll just take some random numbers. Just give here. So this one taken correctly, right? Yeah. Just give me a second. I'll just say take some random numbers. 75. Let me take 90. Finally, I'll just take some random number 66. Let me give console log of, this is the original array, right? I'll just give here original array. This has to be array, just array. We have to mention the array here, and we have to get the sorted array. So I'll just mention the Radix sort of here array, and let me mention the console log here again. So I'll just give here sorted array and again array. Oh, sorry. Just give me a second here. Yeah. Now let me hit the run here. So what happened here? So this has to be capital M. So index line number 25, right? I'll just come here. Just give me a second. Just make this one capital M. So let me run this. Yeah. Now you can see we are having 170, 45, 75, 90, 802, 24, 2 and 6. So now we have 2, 24, 45, 66, 75, 90, 170 and 802. So now we are getting the output, right? This is sorted, right? We are getting the this one in ascending order. Same elements in the ascending order. So you can try for the descending order. So now this works absolutely correct. So let's discuss the time complexity and the space complexity. Right. So just give me a second here. So the overall time complexity would be big O of d into n plus k. So why it is d into n plus k? Where d is nothing but the number of digits that we consider, right? N is nothing but number of elements and k is the digit range. So overall time complexity would be big O of d into n plus k. So when I say digit range, it has to be 0 to 9 for base 10. And what will be the overall space complexity? This is big O of n plus k, where we know that n is number of elements and k is the range of digits. Already we know that one, right? So I'll just mention this one here. This one will be big O of d into n plus k here. And space complexity would be big O of n plus k here. So I have mentioned d is nothing but the number of digits, n is nothing but the number of elements, and k is nothing but the digit range. So same goes with the space complexity. N is number of elements, and k is nothing but the this one range of digits. So here this is it. I hope this is clear. So we are done with the sorting algorithms. Let's see the other algorithms next, right? So this is it. Thanks for watching, guys.